properties. So before we get into all of this fun-filled stuff with logarithms, as always, let's practice our exponent properties that we should know. Because as you saw yesterday in the tables with the graphs, you are going to see some negative exponents. We want to know, of course, how to rewrite them with positives. So remember, if you're on the bottom of the fraction like A is, you just have to move it to the top, and then you can change the power on it. Maybe we can change the power on it. Here we go. Do the fifth. No need to put over 1. That's unnecessary. Now, B. B, of course, I want to change the -3 to a +3 exponent. So I'm going to have to change the fraction, meaning the 1's going to go to the bottom, the 2's going to go to the top. I'm going to have to do the reciprocal. I know that's just 2. I'm just writing it for dramatic emphasis. And then we can change the exponent to a 3. Obviously, simplify it. You really have 2 cubed. What's 2 cubed? 8. Piece of cake. So this is what I'm talking about, having a little bit of a number sense. You're going to see some of these little exponent properties popping up today. So just kind of getting into it here. First glance on C, I was like, oh man, I got to put x to the 4th on the bottom. I'm like, I don't even have to get that carried away. Because when you multiply, you add the exponents. And what do you get when you add those up? It's -4 plus 6. 2. So we don't even have to worry about the negative exponent. That comes out pretty nice. I like that one. That one's an easy one. Okay, so let's talk about what a logarithm is. Now, of course, as always, all this technical jargon, okay, let's just talk about it for something that I promise is very simple. So I know some of us have expressed you don't love logarithms, but I promise I'm going to make this as easy as possible on you. So let b and y be positive real numbers. So basically, they're just letting b and y be the variables today. The logarithm of y with base b is denoted log base b of y. Okay, so first off, remember the base has to be is a subscript. So make sure when you write these, you're putting the base a little bit below the word log, okay? And is defined as the following. Log base b of y equals x, if and only if b to the x equals y. The expression, you can see this here, is read log base b of y. You're like, what in the world is all this craziness? Well, let's start with what we did yesterday. I'm going to go over here to the exponential side first, okay? So exponentials. We saw things like this yesterday. I think we all agree 2 cubed is 8, right? Now, if we want to kind of define this in terms of just some generic variables, not specific numbers. So I'm going to think of this as the base to a power equals whatever answer. Now, to transform this into a logarithm, so I'm going to go back, I'm going to start with the red. So leave a line here, leave a space here. So if I want to rewrite this kind of generic expression as a logarithm, I'm going to put the word log. Our base is what's raised to the power. In this case, it's the letter b. I'm going to write it as a subscript. Now, you're going to hear me say it like 50 million times this chapter. Logarithms and exponentials are inverses. We have talked about inverses a lot in this semester so far. Switch x and y. So y goes to the left, x goes to the right. That's how you can convert between the two forms. So then if I want to actually look at something like the 2 cubed equals 8, I want to convert something with specific numbers, is more so what we're going to be doing today. We're going to have log. Our base is going to be 2. That's what has the power on it. And again, they're inverses. So 8 goes to the left, 3 goes to the right. So we're going to be doing a lot of converting between the two forms today. Exponential to log, log to exponential, and vice versa. We're going to use it to solve equations. We're going to use it to do some graphs, all sorts of things the rest of the chapter. Today we're really focused on converting between the two forms. And just to draw your eye to it, I do have it up here on the board for you too as you're working on the homework, just so it's in front of us, okay? Just FYI. So super easy, super easy. Write the logarithmic equation in exponential form. And you can see they're nice in the directions. You even got a little example. So again, I'm in log form. I want to go to exponential. So my base, of course, is 3. And then I just think, as I'm hitting buttons here on the screen, I just think, of course, we switch sides because they're inverses. 4 is going to come over here as the power, and then I'm going to have 81. And of course, you should always be left with a true equation. 3 to the 4th power does in fact equal 81. Okay, so I know it's all right. All right, let's do B. Now, I got to add some math cheese to all of this. The other way you can kind of think about doing all this, if you don't want to be like, oh my gosh, inverse, switch the sides, all that. So of course, you're starting with the base 10 to the opposite side equals what we have left over, that 1 over 1,000. And I kind of think about it, oh, we got to make like a little horseshoe shape there. That's my cheese for the day. So you just start at the base and kind of circle your way around to it. And again, this is where I said you have to have a good number sense. This is 1 over 10 cubed really with a positive exponent. 10 cubed does equal 1,000. This is a true equation. So that's a quick, easy way to kind of check it. All right, let's do this, guys. So again, I'm going to start at the base, 16, to the opposite side. That's going to come over here to the left. Equals, of course, that 8, we give it a fancy name called the argument, just for vocabulary's sake, equals our 8. And of course, if you punch that in your calculator, it does equal 8. So not a lot of work today, which is the win. You just have to be good at converting between the forms. So now we're going to go from exponential to logarithmic, okay? So our log, now 8's going to be our base. And of course, you're going to hear me say it a million times, they're inverses. So I'm going to switch the sides. 64 is going to come to the left, 2 to the right. Done and done. That's simple today. Okay, let's look at B. So same thing, log, our base is going to be 9. 27 goes left, 3 halves to the right. And I'm assuming you did this last year in Algebra 2. Probably nothing new or exciting, just need a little refresher. Don't let the last one scare you. Just throw some crazy letters on there. Let's see what we can make happen. What's going to be your base on the log? N. Yeah. And then, of course, 10 moves to the left. T to the right. That's crazy, but hey, that's all right. A lot of you are able. Got it. So glance over the front page of your notes. Any questions, anything I can explain, answer, anything? Too easy. All right, let's do this, right? All right, so some other properties. Again, you're going to hear me say it like 50 million times. They're inverses of each other. So think about this. Square root and squaring, cancel. Addition, subtraction, cancel. So a log and an exponential, as long as they're the same base, A and A, cancel. All right, makes sense. Inverses, cancel, I got it. Now, log and the same base on both sides, just like anything on both sides of an equation, cancels. Got it? I'm going to slide this over just a little bit. Now, again, same spiel, exponential, log. Same base as both B's, they're inverses, they cancel. So we're going to use some of those properties today. Now, we already talked a little bit yesterday when we started our graphs with the E in it, the Euler number E on your calculator. We're going to talk about that again here today. So we never write our final answer with a log base E. You're going to put ln, natural log. You just need to recognize your base on it is E. So E and ln, exponential, log, still cancel each other out. So the next round of properties is really the same idea, except I have it in natural log and E form. So natural log and E inverses, they cancel. Same thing. ln on either side, same thing on either side of an equation, cancels. We're basically writing the same stuff here. Okay, third one, E exponential, ln, log base E, cancel. So we're going to use these properties here coming up to simplify some expressions in just a minute. Now, here's where I said you have to have a little bit of a number sense. Evaluate the following function without using a calculator. I know that scares some of us. We will have a couple easy, short, sweet, like me, no calculator quizzes this chapter. We should be able to, the looks on your faces right now, priceless, should be able to do some very simple things like what I'm going to do coming up here by hand. Okay, now, because I'm getting the looks and I know how we feel about fractions, let's do B first because it's easier. Okay, let's do B first. So evaluate that. X is 100,000. To me, that's just irritating. Like, let's just put the 100,000 in here and be done with it. Like, why do we have to have this long-winded expression? So here's what I'm talking about when I keep saying today, you have to have a little bit of a number sense to you. Meaning, so I'm going to keep it, of course, I want to rewrite that 100,000 as 10 to some power. Now, we got to figure out the power, of course, because logarithm, exponential, they'll cancel to whatever the power is. But we got to know what power that is. Well, I know 10 squared is 100, so it's not going to be a squared. What's 10 cubed? 10 cubed, people. 1,000. I'm getting scared. 10 to the 4th. 10,000. So still not it. 10 to the 5th. 100,000. Ding, 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 ding. So I'm going to take that off and put a 5. So this is where I'm saying you have to be able to have a little number sense and know that 10 to the 5th is 100,000. Now it's easy. Log, exponential, cancel, 5. So that's the tricky part, is having that number sense of coming up with 10 to the 5th. Are you ready for the fraction one? This is going to be good. I can already tell it. So of course we're going to put the 1/4 in for x. I'm a little scared for this one too. So again, my overall goal is I want to rewrite this as 16 to some power. Which again, the question mark, the power, that's the tricky part of the hard part of this. Once we figure it out, we can cancel them out and we got it. Now, let's have some little talks here about how we can make this happen. I know 4, of course, does relate to 16. If I want to rewrite that with some sort of operation with 16, because what's the square root of 16? 4, right? So this is equivalent to 1/4, agree? Now, here's where I'm worried, because I don't know how much you get into this in Algebra 2. The square root is a 1/2 exponent. Does that look vaguely familiar? Did you do any fraction exponents? Some yes, some no. Some are like, holy cow, what is happening in here? So just to explain, because I'm like it on homework. So the square root, we don't write the 2 for the square root, but the whatever root it is what the bottom number is on the fraction. So if that was a cube root, I'd have 1/3, 4th root 1/4. Now I think I'm getting there, because I want to make it just 16 to something. So if I put it to the top, I can write it as a -1/2 exponent. So now I'm just going to back up the truck here. My little number sense, I figured out this is the same as to the -1/2. So we did all of that work for what final answer? -1/2. Hardly seems worth it, doesn't it? Yep. So this is the trickiest part of the homework, is you have to have a little bit of number sense about you to figure out how you can rewrite this using the base number. Now, this, of course, is one of the harder style ones. They're not all that crazy on the homework. Like I said, a lot of them are, to me, this is pretty straightforward. Figuring out 100,000 is 10 to the 5th and then just canceling them off. But you have to have a little bit of a number sense about it, okay? All right, this is super easy. Use a calculator to evaluate value, blah, 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 around the 3 decimal places. So on your calculator, I'm sure you know this, but let's just get into it here. So of course on your calculator, you've got your log key here. Now notice, there's no base on it, but really there is. Above it, if you look at second log that has 10 to the x power, the log key on your calculator is default to a base 10. You won't ever see the 10 on it, you just have to know it's in a base 10. So when I go to type that in, I'm just going to hit my log key and then 4/5. And I know I'm in my base 10. I'm going to 4 divided by 5 here. Make it easy. So round to 3 decimals, let's put -0.097 for that. I like these, right? Okay, B, same thing. You guys punch this one in. Just as it appears, you're 1.9. Hit your log key. You won't see a 10. You just have to know it's a 10 and put in your 4.3. Or what do you get when you round to 3 decimals? Everybody likes these rounds. These are the easy ones. 1 point. What do you got? 3 decimals. Perfect. Thanks, Eddie. So any questions typing it in? So even on your homework, because you know I like to be fancy, I might not have put the 10 on. I might just say the word log. If you don't have a subscript specifically in front of you, it is implied or defaulted to be in a base of 10 and you can use your calculator. Now, yes, you can do other bases in your calculator. There's a function in your little math menu, and we'll do that at some point. But today we're just easy peasy doing base 10. All right, solve the following. So here's where we're going to use all of our properties. I like these. We hardly have to do anything. I'm looking at this. I'm like, oh, piece of cake. You have a log base 5 on both sides of an equation. They're going to cancel each other out. Now, this just irritates me. I like it x equals, you know. I'm just going to flip it because I like it to have the variable first, is how I like to roll. So I'm looking at this guy. Oh, log, exponential, inverses, they cancel. And again, I like the variable first, so I'm going to put x equals 2. Okay, so I'm looking at C. Once again, log on the same base on either side of an equation. Anytime you have the same thing on either side, they cancel. And of course, 4 squared. I'm not going to put 4 squared. We're better than that. I'm going to put 16. So I like that. No work. No, hardly any work today, my friends. Okay, use properties to simplify. Okay, all right, same thing I'm looking at. I'm like, all right, I got this. We have an exponential 6 to a power, and we have a log with the same base. Got it. Inverses cancel. Let's just have a quiz on this, okay? All right, B. Now I'm like, okay, B, of course, I gotta do a little bit of work on here because I'm like, 4 and 16. I need those to be in the same value. Okay, we can make this happen. This isn't going to be too crazy. So I want to rewrite 16 as 4 to a power. Well, that's not too hard. 16 is the same as 4 to the what? Squared. So now, of course, I have my log and my exponential inverses cancel. So here's my question. The last thing we have to figure out. What are you doing for an operation, add, subtract, multiply, or divide, between the 1/4 and the 2 that are left? What are we going to do? What is the operation between the 1/4 and the log? Multiply. There's my dramatic time symbol. So we are going to multiply 1/4 and 2. Little fraction work for us. We can do this without a calculator. What's 1/4 times 2? Yeah, done. So easy today. There's not a lot of work, but you have to, like I keep saying, have that little bit of a number sense to you to rewrite the numbers using the base.